each piece represents, and then we'll choose a problem and then move on. A, accumulated value. So let's say 5 years from now, we get such and such amount. That's the accumulated value in the future. P is the principal, which is the amount of money we deposit, let's say, today. Lowercase n, the number of times the interest is compounded per year. Number of times interest is compounded. Recalculated, in other words, per year. R, the annual interest rate. T, time in years. So let's look at a problem. '56 on page 475. We have 55 listed, so we're doing 56. Suppose that you have $6,000 to invest. I'm just copying the information, and then we identify which investment yields the greater return over 4 years. 8.25% compounded quarterly, or 8.3% compounded semi-annually. So that's our question. First, I need to identify the information given here. And then calculate it. Ready? What does 6,000 represent? Very good. What does 4 years represent?
9.
Very good. What does 8.25 represent? Which is 0.0825. I cannot use percentages in the problem. What does this represent? Awesome. And what does this 1.083 represent? This is another R because we have to calculate twice. What does quarterly represent?
4 times a year.
So what variable is it? N equals 4. Awesome. And semi-annually, what does it represent? Very good. And I'm going to add here as the question here. Just calculate what happens in 4 years continuously. Not compared to anything, but I'm just adding here, calculate A for 4 years continuously. So using this formula. Okay? Not to compare. I just want to introduce this so we don't have to go back to it. For continuously compounded interest. First, we answered the original problem, the original question, and then we're just calculating how much we get when we compound interest continuously. Okay. So the first A1 will be 6,000 multiplied by 1 plus 0.0825 divided by how much? 4. Raised to the power of nt, which is 4 times 4. And the second A will be A2, 6,000, and 1 plus 0.083 divided by 2. Everything raised to 2 multiplied by 4. Here, for compound interest continuously, choose a rate.
6%.
6%. Okay, so we're going to look at that one. So let's also write it A3. So A3 equals 6,000 times E to R 0.06, and the time is the same, 4 years. We cannot perform the calculations without a calculator, so let's do just that. So 6,000 in parentheses 1 plus 0.0825 divided by 4, close the parenthesis, caret. If you don't want to put parentheses, put directly 16.
How did you get that? How do you get 16?
Caret 16. I have to multiply 4 by 4, otherwise I have to put parentheses. Is that okay? So then the second one, 6,000 in parentheses 1 plus 0.083 divided by 2, close the parenthesis, caret, and if you don't want to put parentheses for the caret, you multiply 2 by 4 and you get 8, and press enter. No cell phones, please, pay attention. Please, I see it under the table. You should have known that by now. So 6,000, and then multiply by E, and in parentheses, 0.06, multiply by 4, close the parenthesis, and press enter. So we cannot compare the third answer with the top ones because we used a totally different interest rate, so there is no comparison. So here I'm just going to write 7627.49. So now A1, I copy A317.84 and A2 A306.64. So what would you recommend to your friend, your neighbor, your relative, saying if you want more money, you should choose the deal that the bank gives in such a way that the interest rate is compounded, blah, blah, blah. So which one is the better deal? Not by much, but in the long run, it could make a difference.
A1.
Yes, A1, which means at 8.25%, and the interest compounded quarterly, 4 times a year. You get the better deal by getting this amount, depositing 6,000, you get this amount in 4 years from now.
Why did we choose the third one?
I just wanted to show how to calculate. There is no comparison. I just added that in. Has nothing to do with the problem itself. Very good. Any questions now? Okay, I'd like to continue with 4.2. And the title is Logarithmic Functions. So this is an ITH, logarithmic functions. Before we even talk about this, I would like you to give me an exponential function. Any exponential function. No transformations on it. Any pure exponential function that you want to work with. Say it again. Very good. Awesome. This is indeed an exponential function. It's a pure exponential function. Can anyone tell us what is the base? Can anyone tell us or picture the graph already? Is it increasing on all its domain or is it decreasing on all its domain? Right, because the base is
Greater than 1.
awesome. Perfect. So now I would like you to apply this function, 5 to the x, to 3 numbers that you can give me. Give me 3 numbers. Not huge because it's going to... We can illustrate with simple numbers. We don't have to go to very high numbers. I would like a positive, I would like a negative, and also 0. So I'm going to put the 0 in, and I would like you to give me a... I'm sorry, I didn't mean to write anything. I would like you to give me a positive number and a negative number. Which one? Negative 2? Okay. And let's make this one 4. Is that okay? So please give me the y value when you apply 2, 4, 0, and negative 2, when you apply 5 to the x. So how much is this? Awesome. How much is this? Awesome. How much is this? 1 over 25. Perfect. Do we all agree with this? Okay. What did we say about the exponential function, including 5 to the x? Is it 1 to 1 or not? Yes, we wrote that. Does it have an inverse? Yes, awesome. So now I want to go back with an inverse function. So what do I have to show you? That when I apply the inverse function to dictate one number. To, I get what? Exactly. When I apply the inverse function to, I get, because otherwise it's not the inverse function. And when I apply the inverse function to, okay. Otherwise, you will say no. What you are showing us doesn't make any sense, right? Okay, good. The function, the notation for this function is log, which is log. What should the base be? It has to be the same base. There is no way I can apply a function to 625 that has base 3 and I get 4. There is no way I can apply log base 3 to this number and get negative 2. So the inverse function has to have the same base with the original function. Yes. So log base 5 of x. So one more time, how do I read this? Log base 5 of x. Okay, I named the function. We even graphed the function. We didn't even know what it was, but we graphed it. If this were 5 to the x, this will be log base 5 of x. Now, this is 3 to the x. What do you think the inverse function would be? Log of x. Awesome. Thank you. What about, where is my other function? What did I do to it? Okay, here it is. So can anyone now give us the inverse function of 1/2 to the x?
Log base 1/2 of x.
Log base 1/2 of x, indeed. It has to have the same base. Okay, this is all good. But I want you to say, you just named this function. Okay, it's a fancy name. I've never seen this fancy name before. Wonderful. But you have not shown me yet, which I have to agree, that log base 5 of 625 returns 4. I have not proved that yet to you. I did not show that log base 5 of 1 is 0, and I did not show that log base 5 of 1 over 25 is negative 2. I did not. Here's the time in which I will, right here, right now. However, I cannot show that to you without presenting the very, 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 very important concept in this entire chapter. There is not one more important concept than what I'm going to write right now in this chapter. And here it is. I'm going to write it in plain English first. Any log equation can be replaced by an exponential equation, comma, and vice versa. Any log equation can be replaced by an exponential equation, comma, and vice versa. This is plain English. Now in math, log base a of x is a number y. Is this a log equation? It has the left-hand side, it has the right-hand side, and it has a log in it. Now this is the double equivalency symbol. What does this mean? It means that your left creates the right. So if I start on the left, I can get the right. If I start on the right, I can get the left. So here's how we get the left-hand side, which is an exponential equation. Counterclockwise, the base raised to this number equals x. The base raised to y equals x. This, I claim, is the most important concept in this entire chapter. Everything, in my opinion, is based on this. Now, knowing this concept, I am going to show you how I apply log base 5 to 625, and I will recover 4. So, I apply log base 5 of 625, and this is this side. Log, base 5, the number is 625. I am going to say that this is y. I don't know what it is. I don't know how to solve this, but I know it's equivalent to, and please dictate. Change this log equation into an exponential equation and tell me how to write it. So 5 to y, you're right, you're way ahead of me, you always are, equals 625. And now I'm thinking, because this is very important because I need this for this chapter. This is what type of equation? Exponential, because the variable is the exponent. Good. If I'm able to make both sides and present both sides with the same base, this will be very easy to solve. So the left-hand side is as simple as I can get it. Now the right-hand side, what do I know about that number, 625? It can be written with the same base as the base on the left, which is 5, and raised to what power? 5 to the 5th is not 625, to the 4th. That's okay. So now here's how I think. I don't want you to think that we are simplifying the 5s or reducing the 5s or doing anything to the base. We're not. Here's how we think. Two numbers are equal and they have the same base. What has to happen to their exponents? They must equal each other. So therefore, y, which is this number, must equal. So now we proved that when we apply this function to 625, what do we get back? Exactly 4. Now we're going to apply log base 5 to 1. Ready? Log base 5 of 1 is y. I don't know what this equals to, but I know that any log equation can be replaced by an exponential one. And I'm ready. Please dictate. 5 raised to y equals 1. In this particular case, I asked myself a slightly different question. 5 raised to which number is 1?
0.
It must be 0. So then y is 0. So now we proved that log base 5 of 1 returns for sure what? Last one. Log base 5 of 1 over 25 is y. I don't know what that is. But I know that this is a log equation. And I know it can be replaced by an exponential one. But how do I write it? Raised to equals. Awesome. Again, I have the same dilemma. If I can present both sides with the same base, I'm in business. What if I can't? Yes, Jen?
5 to the negative 2.
Yes. So the left-hand side is 5 to y, and the right-hand side is 5 to negative 2. So I don't eliminate, I don't simplify, I don't cross out, I don't delete anything, I just think. Two numbers are equal and they have the same base. What is the relationship between the two exponents? There is no other way. Because if this is 15, 5 to 15 does not equal 5 to negative 2. So then y must be negative 2. Without even knowing, we solved 3 log and exponential equations. Good. Now, what did we say about exponential? Friendly or not?
Friendly.
Awesome. What did we say about log? Not friendly. So let's review this one more time. The exponential is defined. What is its domain? Perfect. Thank you. What is its range? Remember the graph. Very good. And now what about the log? That's why I said log is trouble. Like rational, like square root. What is the domain of log? 0 to infinity is the range of the exponential. And what is the range? Right. Again, we have the same two shapes. We already graphed them. Okay? So let's graph one more. So let's say f of x equals log base 2 of x. Let's graph this. Pure exponent is pure log function. Then we're going to look at one with transformations. Okay. Domain, please. Pure log function. Very nice. Thank you. Domain 0 to infinity. Because the base is 2, I'm going to use powers of 2. Let's say 1 over 4, 1 over 2, 0, 1, and 2. I don't know what this is. I have to take it aside, and I'm going to write this. F of 1/4 equals log base 2 1/4. I have to plug this in. I don't know what this is. I'm going to say it's y. I don't know how to calculate this because I don't know how to solve a log equation. But I know that I can change it into... Good. I'm ready. I always start with the base. I always start with the base. To the y equals, very good. The left-hand side is as simple as it gets. Now the right-hand side, I need it with the same base, if possible. I chose these numbers so I can have the same base. 2 squared will be 4. Very good. To negative 2. 2 raised to negative 2. I don't delete, I don't cross out, I don't simplify. I think. 2 numbers are equal, and they have the same base. What has to happen to the exponents? Yes, so then definitely y must equal log base 2 of 1/2. Log base 2 of 1/2 is a number y. I have no clue, but I know I can change it into raised to y equals, yes, indeed. So 2 raised to y equals 2 to negative 1. I don't delete, I don't cross out, I don't do anything, I just think. 2 numbers are equal and they have the same base. What has to happen with their exponents? So here's negative 1. Now I have log base 2. Ooh, nobody said anything. I put 0 between 1/2 and 1. Lost my mind. Because I put 0 in the middle, and sorry about that. Okay, log base 2 of 1. I have no idea what that is. But I know that this can be replaced by 2 to y equals 1. I know, I think. Okay, 2 raised to which power is 1? It must be 0. Finally, when I put in 2, 2 raised to which power is 2? 1. So I want to investigate what happens this way and what happens this way. I already know what happens, but let's investigate. To this side. 0, 1, 2, 3, 4, 5, 6, 7. Where am I going? This side. -1, -2, -3, -4. Good. So let's graph this function. Since the base is greater than 1, will the function be increasing or decreasing? Yes, both exponential and log will be increasing if the base is greater than 1, and both of them will be decreasing if the base is less than 1. Okay, so please dictate the first ordered pair you want me to plot.
1/4 -2.
You want 1/4 -2. Kind of difficult, but I'm going to say here. Next ordered pair.
1/2 -1.
Next ordered pair.
1 0. 1 2 1.
So this is log base 2 of x. Is this function 1 to 1?
Yes.
Can anyone give us right here, right now, f inverse? Yes, say it louder. 2 to the x is the inverse function of log base 2 of x. Very good. So let's work on some problems and also transformations. So let me choose a function, and you'll tell me what to do with it. Yeah, let's do 54. On page 490. In 54, we are given h of x, 2 plus log base 2 of x. They want us to use transformations on this function. Which is the base function used to create this one?
Log 2 of x.
Very good, awesome. Log base 2 of x is the base function. What is the only transformation on this function? So log base 2 of x plus 2, which means, am I changing x or am I changing y? If you say x, then, of course. If you say x, it means left and right. If you say y, it means up or down. Very good. So this is up 2. Is this function increasing or decreasing? Because if it is increasing, I will graph it like this. If it is decreasing, I will graph it like this. Increasing or decreasing?
Increase.
And it crosses at always. Very good. So this is log base 2 of x. What do you want me to do with this function? You already told me. Up to. So here's what I do. This is my marker. 1, 2. This point moves up here. Does the vertical asymptote change? No. Now, let's say I create a function that is this. Let's say I have h of x, which is negative log base 1/2 of x plus 1 plus 2. What is the base function that I used to create this one? Yes, awesome. Log base 1/2 is of x. That is the base function, pure function, pure log function. First transformation in order of operations on this one. What is it?
X plus 1.
Very good. So I have log base 1/2 of x plus 1. Which shift is this? And what am I changing?
1 to the left.
Very good. By comparison, you see that this is x and this is x plus 1. I'm changing x, so it's left 1. Good. Number 2 is a transformation of number 1.
Plus 2.
I'm too far. Not yet. In order of operations.
Oh, the -1.
Yes. Log base 1/2 of x plus 1. What transformation is 2 on 1? Exactly. Reflect with respect to the x-axis. Awesome. With respect to the x-axis. Very good. And what transformation is 3 on 2? Very good. Negative base 1/2 x plus 1 plus 2 up 2 indeed. Good. How do I graph log base 1/2 of x? Is it increasing on all its domain, or is it decreasing on all its domain? Decreasing. Very good. So not this, but this. Very good. So log 1/2 of x. Awesome. Now what? This function has an asymptote. Can anyone dictate the asymptote of this function? Awesome. Thank you. X equals 0 is the vertical asymptote. Now, I need to shift this left 1. What do I have to shift first? So here's the graph. Here's the graph, and I want to do this. I have to shift the asymptote first from x equals 0 to, very good, to x equals -1. Here's my marker. Where do I move this point? To the, exactly. So now this is the graph of log base 1/2 of x plus 1. Very good. Now what? You told me to flip it. Okay, I will flip it. Here it is. It's flipped. Then you told me to do what? So where does this marker go now? Very good. So this is negative log base 1/2 x plus 1 plus 2. Awesome. Any questions?
How did you get the x equals -1 for the asymptote there? Finish that part.
The original one is x equals 0.
Yeah.
So when I shift the graph 1 to the left, I have to shift the asymptote first. When I shift the graph with horizontal asymptote up and down, I have to shift the horizontal asymptote first. When I shift the graph with a vertical asymptote left and right, I have to shift the vertical asymptote first. Okay, I want to look at an application so you can see how important this is. And also find a couple of domains. Looking again, 71, 75, so everything 75 to 103. Perfect. Okay, so let's look at problem 78. In problem 78 on page 490, we're asked to find the domain of log function. So f of x equals log of 7 minus x. Say it again. Thank you. Thank you. Let's special log functions. Thank you. And I'm going to put them together with their corresponding exponential ones. So log and exponential. I'm going to write them one more time. So f of x equals 10 to the x is the common, we wrote that already, common exponential function. Its corresponding inverse function is log of x. So the common log function. So let's look in the graphing calculator. Thank you, Tim. So let's look in the graphing calculator right here. It's the same key. Do you see I have it in blue, 10 to the x, and the key actually is log. Log by convention means base 10. So if I want to determine, let's say log, common log of 8, press enter. If I want to determine common log of 10, what do you think I will get? Exactly. 10 to which power is 10? What awesome. Very good. What if I want log of 1,000? Correct? What power I raise 10 to get 1,000? It's 3. Good. So now the natural exponential, e to the x, natural exponential, we talked about it a few minutes ago. And the corresponding is ln x. So instead of writing base e, we write ln. Instead of writing base 10, we write log. So this is natural log function. So let's look in the graphing calculator. It's the same key with e to the x, but it's ln. So it's the log having base e, ln. So ln 4 is 1.386, means e to this number, so second, and e to the previous answer, what should I get when I click enter? 4 indeed. 4 indeed. Very good. So now we're coming back to our problem. Tim already noticed, and thank you, Tim. He said no base. He's right. It's no base because it means common log, and it means what base? 10. We're asked to find the domain of this function. What do I have to write and solve in order to find the domain of this function? What do we know about log? Log must be applied to which type of numbers? Exactly. But this time I don't have plain x. I have log applied to a different expression. If the expression were x, I would have sent 0 to infinity. But the expression is not x. So I have to write something and solve it in order to find the domain. What do I have to write? What am I applying log to? What am I applying log to? 7 minus x must be what type of number so I can apply log to it? Exactly. If the quantity I apply log to is not a number greater than 0, I cannot apply it to. Good. So I bring x to the other side, so x less than 7. So what is the domain of this function? Very good. To 7 indeed. Let's look at another one. Let's say 76. We have f of x equals log base 6. No, not 6, 5. Doesn't matter. Of x plus 6. What do I have to write I'm asked the same question. I need to find the domain. So what do I have to write?
X
Yes.
plus 7. X plus 6.
Yes.
Greater than
Very good. In order to find the domain of this function, x plus 6 must be a quantity that is positive because log cannot be applied to it otherwise. So then x is greater than -6. So what is the domain of this function?
-6.
With a parenthesis to infinity. Indeed. Any questions? Yes, of course.
So why don't you do any -5?
Because we're talking about the domain. 5 is the base. 5 has nothing to do with the domain. Is that okay? Good.
X plus 6 raised to 15.
If you want to change it into an exponential, then you will have 5 raised to whatever equals x plus 6. But we are not asked to solve anything. We're asked to find the domain. So, for example, when we have the function f of x equals 1 over x minus 1, we're not asked to change the function into anything. We're asked to find the domain and identify that x cannot be 1, so the domain is negative infinity to 1, union 1 to infinity. We're not asked to change it into anything else. The same thing here. I'm not asked to touch this. I'm asked to identify what values I can plug in. And I cannot identify that before I solve this inequality. And now I can tell you, if you want me to evaluate this function for you, make sure you give me a number between -6 and infinity, because otherwise I will not be able to give you a number back. If you say plug in -10, I can't. -10 plus 6 is -4, and you cannot apply log in any base to -4. Better? Okay. So I have a couple more minutes. If you remember, we have 10 minutes extended. Okay. I know you're ready to pack and go. Okay. Problem 119. On page 491. I want you to see an application and how important this function is. Students in psychology class took a final exam. As part of an experiment to see how much of the course content they remembered over time, they took equivalent forms of the exam in monthly intervals thereafter. The average score for the group, f of t, average score, after t in months, was modeled by the function f of t equals 88 minus 15 natural log t plus 1 for t between 0 months and 12 months. What was the average score on the original exam? What does this mean? What am I asked to find? The average score on the original. Say it again. Exactly. I have to find f of 0. We'll do that with a calculator in a minute. What was the average score after 2 months? What am I asked to find? Very good. After 4 months. After 6 months. After 8 months. After 10 months, after 1 year. And then sketch the graph. Okay. Ready? So let's put it in the graphing calculator in y equals. The function is 88 minus 15 natural log, and in parentheses x plus 1, we don't have t. And then I go to second and table set. I always have to change this because it goes back to default. So then second and table, and I will plug in what I need. 0, enter, 2, enter, 4, enter, 6, enter, 8, enter, 10, enter, 12, enter. I will copy all these numbers, but what will I say? A year from now, so I'm giving you a test today, and I test you every month. So the average score today on the test was 88%. Very good. So what is expected if this is true, this model is correct? How much would you remember potentially if this works for everyone? How much will you remember 12 months from now? About 50%. About 50%. So it appears that it decreases. And now if I want to graph, so, oh, I didn't mean to change, I'm sorry. So if I want to graph, I go to the viewing window. What are the x values? Because I have to choose. Exactly. That's what I care about right now. So I'm going to say 0 to 12 with a scale of 2. Now, what averages did we get? The top was, and the bottom was?
49.
Roughly. Good. So I definitely want to get to above 88. So I'm going to say y minimum, okay, I can put 0. But y maximum, 100. And with a scale of 20. And now I want to graph. But I did some work, right? I calculated so I know where to look. Where's the viewing window? So here it is. Starts at 88 when x is 0. And when x is 12, roughly 50%. And this could have not been modeled with a rational function, with a polynomial function, with a quadratic, or no. Only the exponential, and in this case log, worked. Any questions from